Alright, so now we're going to talk about trigonometric ratios. And so what this is it deals with sine, cosine, and tangent. And we can use that to find different angles or different sides of particular right angle triangles. Alright, first things first, let's talk about what a trigonometric ratio is. A trig ratio is the comparison of two sides of a right triangle, okay? Ratio meaning it's a fraction and it compares two sides of a right triangle. Okay, so let's define a few things. Opposite, when I say opposite, what I'm meaning is the side opposite, the side across or opposite the angle. Okay, so across is that second blank there. So if you're looking at an angle, use this triangle as an example here, and this is the angle in question. When I say opposite, I'm meaning the one across from it, right? Right here, okay? Adjacent is the one that lies right next to it. Okay, now there's two that lie right next to it. One of them is going to be the hypotenuse, though. Okay, so we're not talking about the hypotenuse. We're talking about the one that's lying right next to it, which would be this line here. And our hypotenuse obviously is the long side opposite the right angle. So again, trig ratios, we use those three types of ratios. We use sine, cosine, and tangent. Instead of writing it like sine, usually what you'll see it as is the sin for sine, cos for cosine, and tan for tangent. That's how it's usually seen, is like that in the abbreviations. Those are the three main functions in trigonometry. And these three functions help us find sides when we know angles, and they help us find angles when we know sides. Okay, so essentially we build these ratios based on if we're using sine, cosine, or tangent. Okay, in sine we use this fun little abbreviation. We use SOH. S-O-H. Okay, because sine, the ratio that we need to use with sine ratios is the length's opposite leg to the length of the hypotenuse. Okay, the length opposite leg to the length of the hypotenuse. So what I mean by that is if we were trying to find the sine of A, we would need to use the opposite leg, which is A here, over the hypotenuse, which is C. Okay, that's where the O opposite and H hypotenuse come into play here. Okay, so that would be A over C. So the sine of A is A over C. The sine of B is opposite over hypotenuse, so it'd be B over C. Okay, cosine is the same type of thing, except for cosine we use the ratio of the length's adjacent leg. So that's cosine C, A for adjacent, to the length of the hypotenuse. That's the ratio we use for cosine. Okay, so again, cosine of A is the adjacent leg over the hypotenuse. And if we were trying to find the cosine, adjacent meaning the one lying right next to it would be B over the hypotenuse, C. Okay, so the cosine of A is B over C. The cosine of B, adjacent over hypotenuse, would be A over C. Okay, and finally we have this tangent. Tangent we use TOA, T-O-A. Okay, T standing for tangent, O opposite, A adjacent. So the tangent is the ratio of the length opposite leg to the length of the adjacent leg, or tan of A, opposite over adjacent, that'd be A over B. Or the tangent of B, again, opposite B over adjacent A, is how we take a look at that, okay? And I know this is a lot of really difficult information. I'd really highly encourage you to watch the video maybe a couple of times in this area and try to make sense of it. Alright, for example 1, we're trying to write each trig ratio, remember just a fraction, as a fraction and as a decimal rounded to the nearest hundredth, okay? So if I have the sine, remember sine is SOH, SOHCA, TOA, sine of J, that means the opposite over the hypotenuse. First thing we need to do is identify where that angle that we're talking about is. The sine of J being opposite, so 60, over the hypotenuse, which is always across from the right angle, would be over 61. That's how we would write that trig ratio as a fraction, and obviously as a decimal, all we would have to do is do 60 divided by 61. Use a calculator for that. We get 0.9836, round to the nearest hundredth would be 0.98. So 0.98. Same type of thing here for cosine though, a cosine of j. Remember SOHCAHTOA, the c is adjacent over the hypotenuse. Okay, so we're going to look at the adjacent leg, which is this 11, over hypotenuse, which is 61. So it'd be 11 over 61. Again, writing that as a decimal, we would just do 11 divided by 61 is 0.18. 0.18. Okay, and if we're trying to find the tangent of an angle, tangent of k, remember tangent, the TOA part, is the opposite over the adjacent. So we're looking at this angle right here. Opposite of k is 11. Adjacent of k is 60, which means that this is going to be 11 over 60. And what you'll see, 11 over 60 is very similar. It's a little different, but it still rounds to the nearest hundredth as the same as cosine of j did. So it's 0.18. Okay, so example 1 dealt with trying to find the trig ratio based on sides. Example 2 deals with trying to find trig ratios based on angles, okay? And we're going to need to round to the nearest hundredth again. But the real quick thing that I want you guys to make sure you do is if you have a calculator with you, I would get a calculator out. But you need to make sure you change your calculator mode to degree instead of radian. And how you do that is you go to mode. And you can see I've already done it here. You go down to the radian. Usually most of the calculators are already clicked like this. You have to go over to degree and press enter, and then you're in degree mode. That's the very important part. If you don't do that, you're going to get different answers. So if we were to try to find the sine of 52 degrees, you'd press the sine button, which I'll put this up here. You see sine, cosine, and tangent are these three buttons. You'll press sine of 52, enter, and we get that ratio now. The sine of 52, the ratio of the sine of 52 degrees is 0.79 if we round up. So 0.79. The cosine of 19, again, we're just going to press cosine this time, of 19, press enter, we get 0.95. 0.95. And finally, the tangent of 65, you'll press tangent, go to 65, enter, and that's going to be 2.14. 2.14. Okay, so what that does is that gives you how to find the trig ratio based on degrees.